Welcome back. In this video, we're going to continue our study of word problems, and we're now going to solve rate times time equals distance problems, money and investment single variable word problems, meaning we're going to still continue to work with one variable. We're going to begin by looking at rate times time equals distance problems. There are three different scenarios that we'll see in rate times time equals distance. The first scenario is when the objects or items or trains or cars or whatever are traveling in opposite directions. So you need to read the problem and determine whether vehicles are traveling in opposite directions, or you need to see if it's a round trip, or you need to see if it's a catch-up problem. So an opposite direction problem would be a problem in which both things start in the same place and travel away from each other. Or it's possible that they start away from each other and move towards each other. Now, here's that second example, is still one in which they're moving in opposite directions, but they're moving towards each other. So in an opposite direction problem, the distance of one vehicle and the distance of the other vehicle added together equals the total distance. Okay, and I do draw the diagram here. So distance 1 and distance 2 added together equal the total distance. So if I start here in the middle and I have somebody going from St. Louis to Washington, D.C., and I might have the other one going from St. Louis to Denver, they are going in opposite directions. So the distance of this guy going to D.C. plus the distance of the guy going to Denver equals our total distance. And of course, we're going to ask ourselves every time then, we may not have distance, but what makes up distance? Well, rate times time equals distance. So what we'll look for is a rate times time of the guy going to Denver, and we'll look for a rate times time of the guy going to DC. So, and then we'll know to add those two rate times times, the rate times time of one plus the rate times time of the other will be our total distance. The other possibility is round trip. Okay, round trip is out and back. So in a round trip, we'll start somewhere, we'll go out, and then we'll come back. Well, the distance out is equal to the distance back. It's like you traveling to school. As long as you take the same route to school as you take back home, that's round trip. So your distance out equals your distance back. And of course, what is distance but rate times time? So we're going to look for your rate times time out and set it equal. So your rate out times your time out is going to equal your rate back times your time back. So distance out, rate times time, equals distance back, or rate times time. So distance is rate times time. So whenever you see distance, you got to think, I need a rate and a time. I need a rate and a time, whether you're going out or you're coming back. The third option is what I call a catch-up problem. And a catch-up problem might be like somebody has a head start, okay? Your little sister takes something from your room, she grabs it, ditches out, okay, she gets out of your room first, she's sprinting down the hallway and down the stairs, and you are trying to catch her. You come from behind, and hopefully you're faster than your little sister, and you finally catch her, okay? So what do you know about the distance your sister covered and the distance you covered? Well, once you catch her, you two have covered the same distance. So the distance of one will equal the distance of the other when they finally caught each other. So a catch-up problem. Okay, well, what's distance? Well, rate times time and rate times time. So in a catch-up problem, the rate times time of one person will equal the rate times time of the second person, or the distance 1 equals the distance 2. And we will use our charts to solve these problems. Okay, so we'll use rate, time, and distance to help us break this down. If you get good at it, you might not need the charts. But this is consistent with we multiply across, okay, and we add down. We'll add down our tables. So if we have one person and another person or another vehicle and a rate and time, and then we need to determine whether it's a catch-up problem or round trip, and then we need to figure out what to do with our rate times time and our rate times time. Okay? So let's take a look at some sample problems. First one, 2 trains leave St. Louis at the same time. One train departs for New York and the other for Los Angeles at a rate 6 miles per hour faster than the New York bound train. So it sounds like the Los Angeles bound train is going faster than the New York bound train. And they're both leaving from St. Louis. So here's another example of where a diagram will help you. So if we're in St. Louis and one is going to New York, you do need some prior knowledge here. You got to know where New York is. And the other one is going to LA. So we got one going from St. Louis to New York, one going from St. Louis to LA. In 30 minutes, the trains are 45 miles apart. Well, the 45 miles, that's our total distance. That's how far apart they are. Okay? And we need to see this as an opposite direction problem. So we know if it's an opposite direction problem, the distance 1 and the distance 2 will equal our total distance. So distance 1 plus distance 2 equals the total distance. So we're well on our way to coming up with our equation here. We're not trying to answer the question, we're trying to come up with an equation. Then we'll use our equation and use our algebra to answer the question. Let's go ahead and fill in our chart. Okay? We should know the rate of the New York and the LA bound trains, or at least know how to represent the rate. One train departs for New York and the other for LA at 6 miles an hour faster than the New York bound train. So the LA bound train is whatever the New York bound train is plus 6. But we don't know the rate of the New York bound train, but we can express it as x. The time is 30 minutes, and this is somewhat of a trick here. 30 minutes is great, but we can't use 30. Time, because our rate is in hours, our time must be in hours. Okay, this is a good thing to write in your notes. We must have like units of time. Write that in your notes. We must have like units of time. So if we're working in miles per hour, that means our time must be in hours. So 30 minutes is 1/2 of an hour. And the distance, well, we're not going to use 45 miles. That's the total distance apart. The distance is rate times time. So the distance of the New York train is 1/2 x. The distance of the LA train is 1/2 times x plus 6. Right? We multiply across our chart. Now we're going to add down. And sure enough, the distance of the New York bound train plus the distance of the LA bound train, or distance 1 plus distance 2, or in our case, rate times time 1, 1/2 x, plus rate times time 2, 1/2 times x plus 6 equals our total distance of 45. And to get rid of the fractions, I would multiply everything by 2, which would give me x plus 6 equals 90, which is 2x plus 6 equals 90, 2x equals 84, x equals 42. So x is the rate of the New York bound train. So the New York bound train is 42 miles per hour, and the LA bound train is 6 miles an hour faster. 42 plus 6, 48 miles per hour. Second problem is an investment problem. In this question, we have Alex invested part of his $10,000 inheritance at 4% annual interest and the remainder in a CD that pays 6% annually. After 1 year, Alex earned a total of $520 interest on these investments. How much was invested at each rate? Again, we're going to use our chart to identify a variable, set up an equation, and solve and answer the question. So, well, this is like rate times time, but now our rate is going to be interest rate, a percent, and the amount is like time is going to be our principal. Okay, so the amount we invest times the interest rate will give us the interest earned. So we'll multiply across, we will add down. So our two investments, well, we have a 4% investment and we have a CD that earns 6%. So the rate of the 4% investment, I'm going to hedge a little bit here. I'm going to multiply by 100 right away is 4, and the 6% rate is 6. His total amount invested is $10,000. Well, how much did he invest at each? Hard to say. We don't know either, but if we call the 4% X, then the CD is 10,000 minus X, right? If he invested $1 at 4%, then he invested 10,000 minus 1, or the rest of the money, 9,999, at 6%. If he invested $1,000 at 4%, well, he must have invested 9,000. How did we get 9,000? We went 10,000 minus 1,000. So if he invests X dollars, that must be 10,000 minus X. So we've got the amount of interest earned. It's 4x. And we have the amount of interest earned on the CD. It's 6 times 10,000 minus x. And we have the total interest earned. That is 520. So we have our equation. The interest on the 4% plus the interest on the 6% will be our total interest. So 4x plus 6 times 10,000 minus x equals 520. And actually, I should have left this as 0.04 and 0.06. So now we're going to get rid of our decimals. Multiply everything by 100. We get 4x plus 6 times 10,000 minus x equals 52000. That's why I had to change that, to make sure I changed my interest earned. And I think I'm going to let you guys finish this up. So 4x plus 60,000 minus 6x equals 52,000. And I will let you solve that and answer that question, and you can bring that to class. I did the heavy lifting for you there. Let's go to our final word problem. We have a collection of nickels and quarters that has a total of value of $14.60. there are 28 more nickels than quarters. Find the number of nickels and quarters. So our items we're working with nickels and we're working with quarters. Okay? And the rate or the percent or the value of a nickel. What's the value of a nickel? Well, it's 5 cents. And the value of a quarter is 0.25. The amount or the quantity of nickels, there are 28 more nickels than quarters. So depends on what you want your unknown to be, but I'll make Q my number of quarters, and I'll make Q plus 28 my number of nickels. Then my value of my nickels is the price of a nickel, hopefully you know that's 5 cents, times Q plus 28, quantity times price. And my value of quarters is 0.25 times Q, and then my total value of my coin collection is $14.60. So the value of the nickels plus the value of the quarters equals my total value. So 0.05 times Q plus 28 plus 0.25Q, the quantity times the price, or the rate times the time, plus the quantity times the price, or the rate times time, or the rate times amount, same thing, equals $14.60. So we're always doing the same thing here. Multiply by 100, and we get 5 times Q plus 28 plus 25Q equals 1,460. And, well, I'll finish this one up for you. 5Q plus 140 plus 25Q equals 1,460. So it looks like we have 30Q plus 140 equals 1,460. We'll subtract 140 from both sides. And we get, I'm going to go over here where I got some room, 30Q equals 1,320. Divide both sides by 30, and I get Q equals, well, I can do simple math, 132 divided by 3, and I get Q equals 44. So I have 44 quarters and 72 nickels. And let's see if that makes sense. I think that works. 72 nickels is $3.60, and 44 quarters is $11. And sure enough, that adds up to $14.60, and that works. So there are some good examples of some money problems, some investment problems, and a rate times time equals distance problem. But make sure with rate times time equals distance, you understand the difference between opposite directions. Rate times time plus rate times time equals total distance. Distance 1 plus distance 2 equals distance. Round trip, the rate times time of the trip out will equal the rate times time of the trip back, or distance out equals distance back. And the same goes for a catch-up problem. So with that, you can answer that one question, and I will see you in class.